Hi everyone, I'm Anusha and my friend Atishay and Sai Teja will be presenting our project titled Stock Price Prediction. Now let's move on to the introduction slide. Stock price prediction is challenging due to the high volatility of stock markets. This project aims to develop a machine learning based system to predict closing stock prices by analyzing historical data. We used advanced algorithms like LSTM and LMS to provide insights into future price trends. A user friendly web interface was designed for stock traders, researchers, and analysts. Then comes the motivation. Business rely on customer satisfaction and feedback, often linked to social media sentiment which influences stock markets. Manually analyzing feedback is time consuming and error prone. This project automates analysis to derive valuable insights. Now, coming to the problem statement. Time series forecasting is essential for predicting stock prices, which are dynamic and influenced by multiple factors. We use LSTM, a neural network optimized for sequential data, to achieve accurate predictions. Now let's review the existing and proposed systems. Existing system. Existing stock market prediction systems use models like decision trees, SVMs, and regression for trend analysis. Advanced AI methods, including LSTM networks and neural networks, capture complex patterns. Proposed system. Prediction approaches include statistical models, example logistic regression, and AI methods like MLP, CNNs, SVMs, etc. This project uses LSTM networks for precise stock price prediction, leveraging their ability to analyze sequential data effectively. Now let's discuss the datasets used in this project. We used Alphabet in Google, which contains historical data for Google's Class C stock analyzed for movements. Then comes the Nifty 50 index, which tracks the top 50 companies on India's national stock exchange. And then comes the Reliance Industries Limited, which provides the historical data for one of the India's largest companies, showcasing stock performance. The key attributes include date, which is the trading day, open, starting price of the day, high and low, which are the maximum and minimum prices, close, which is a final trading price, adjusted close, adjusted for dividends and splits, and then comes the volume, which is the number of shares or contracts traded. Now let's discuss the system architecture. First, pre-processing of data. We begin with the data set and divide it into input-output components suitable for supervised learning. The data is then scaled into a range of -1 to +1 to normalize it, which helps improve the performance of our predictive models. Finally, the data is split into training and testing subsets, preparing it for model development. Next, the overall architecture. It has a data set where we start with the raw data, then it goes through the pre-processing method, which the data undergoes cleaning and normalization to ensure consistency and readiness for analysis. Then goes with the training test split. The data set is divided into training and testing parts for model evaluation, and then the model construction, where a predictive model is constructed using advanced algorithms like LSTM under various conditions to enhance the accuracy. Prediction. Once the model is trained, predictions are made on the stock data set. Then comes the evaluation part, where the model's accuracy is evaluated to ensure its reliability for stock price prediction tasks. This structured approach ensures that the model is accurate, efficient, and reliable. Now, Atisha will continue.
Now let's dive into the model selection process. We use two key algorithms for this project. LMS, least mean square algorithm. The LMS algorithm is designed to minimize the error between the predicted output and the desired output. The key inputs include the input vector, desired vector, learning rate, and filter order. The outputs are the filtered response and filter error, allowing us to refine the prediction model iteratively. LMS spread algorithm is predictive extension of LMS designed specifically for forecasting stock prices. It takes into account additional parameters such as quantity of days to predict to generate more precise future price estimates. The algorithm dynamically adjusts the filter response and error based on the prediction length, ensuring improved accuracy for stock price forecasting. Moving on to the next slide, here we'll discuss the implementation of the project. The tools and technologies we use here is Python 3.5, Google Colab, TensorFlow, Flask, HTML, CSS, and JavaScript, also Matplotlib. Moving on to the next slide. Here I explain the process overview. Data processing. Raw data was normalized using min-max scaling to ensure feature consistency. Key time series features such as open, high, low, close, adjusted close, and volume were prepared for input into the predictive models. Model implementation. LSTM model. Sequential neural network architecture with input forget and output gates. Configured with 15 neurons, the Adam optimizer and mean squared error at the loss function. The dataset was split into 75% training and 25% testing. Trained over 100 epochs to ensure convergence. LMS filter, an adaptive algorithm optimized by minimizing prediction error. The predicted output was generated using delayed input and updated weights. This comprehensive implementation ensures that the models are both accurate and efficient. Moving on to the next slide. I'll explain here the UML diagrams. Use case diagram. The diagram represents the interaction between the admin, user, and the systems model. The admin is responsible for managing the training and testing processes of all three algorithms, LMS, LSTM, and LSTM with LMS. Adam with can view admin can view the accuracy of each model and evaluate the results based on performance. The process extends to include comparison and improvement as required. The user interacts with the system to get predictions and results from the trained models. Users are not directly involved in the training or testing process, focusing only on accessing the outputs generated by the models. Workflow: each model, LMS, LSTM, and LSTM with LMS, includes training and testing phases. Predictions are generated after training. Results and accuracy are calculated and extended for further user interaction. The diagram highlights how both admin and user engage with the system at different levels, ensuring functionality across training, evaluation, and output stages. Activity diagram. This diagram provides a step-by-step visualization of systems overflow, input dataset, then the processing. Coming to the algorithm selection, here I would explain something. The system offers three algorithm choices: LMS, LSTM, and LSTM with LMS algorithms. Training phase. Based on the selected algorithms, the system trains the corresponding model. If I could skip for the LSTM with LMS, combines the strengths of both approaches to improve predictions. Once trained, each model generates predictions for stock prices. Accuracy calculations. All predictions are evaluated to measure the model's performance, ensuring the best results of the user. Now, moving on, my friend Teja will explain the next slide.
So coming on to this slide, this is the same UML diagram explained by Atisha. So moving on to the next slide. Now let's review the evaluation performance measures of the LSTM model using different datasets like Google Nifty 50 and Reliance. Coming to the Google dataset, as the number of epochs increase, we observe improvements in both accuracy and error metrics. At 10 epochs, the accuracy is 93% with MAC of 207.66 and RMAC of 14.41. By 50 epochs, the accuracy is 96.99. And for extended 10 to 400, accuracy stabilizes above 97%. And the same goes with like Nifty 50. At 50, you can have a look, that's 97.93. And it peaks at 98.67 accuracy by 400 epochs. And you can compare that with the Reliance as well. So moving on to the next slide, let's evaluate the performance of hybrid LSTM with LMS model for the Google Nifty 50 and Reliance datasets. Coming to the first Google dataset, the initial performance at 10 epochs, the model achieved 92.56 accuracy with MAC of 339.55 and RMAC of 18.42. And the performance at 50, you can have a look, that's improved to 94.75. And coming to the extended epochs, by 500 epochs, its accuracy is stabilized at 95.58, so showing minimal gains beyond 50 epochs. And the same you can have a look for Nifty 50 and Reliance as well. So here the key observations are: the Reliance dataset achieved the highest accuracy across all epochs, stabilizing at 97.52%, and the Nifty 50 dataset showing significantly accuracy gains, particularly in the earlier epochs. Coming to the Google dataset, it achieved steadily improvements with diminishing returns after 50 epochs. So moving on to the next slide. Finally, let's discuss the future directions for this project. The cryptocurrency prediction. Cryptocurrencies being highly volatile and dynamic provides an excellent opportunity to further test and improve our predictive algorithms. And the sentiment analysis integration, implement sentiment analysis for financial news and enhance prediction accuracy. And the model optimization, further optimize the models to reduce predict time and improve accuracy. Moving on to the next slide, let's wrap up this with the conclusion of the project. This project focuses on predicting the closing stock price of a given organization. To achieve this, A web application was developed using both LMS and LSTM algorithms for accurate prediction. The result demonstrated the effectiveness of the system, achieving over 95% of accuracy. And these are the references. And with this, we conclude our project. Thank you.
Thank you.